Hey, this is Jeff again. We're going to be talking soft washing. We're talking about the chemistry of soft washing. So, all the different types of chemicals we use, and why we use them, and what result we expect to get from them. So, you've got those three major components. Like, what is the nature of the problem? What is the chemical or solutions that we would say this is the appropriate product to use? And then how do you do that, and why do you what is the result and why? Like, put all that together. Okay, that's what we're going to put together in the chemistry. So categorically, as we talk through these things, whatever I bring up in this lesson and throughout your experience as a soft wash tech, you're going to be thinking of two categories. It's inorganic and organic. You've already heard those terms. So inorganic is your non-living stains, rust stains, efflorescence, graffiti, things that are stains that are not alive. Okay, dirt, for that matter, is inorganic. No, dirt is not organic, not according to the modern definition of what organic means. But in the sense of what we're saying, organic means living stains, mold, mildew, algae, bacteria, fungus, moss, lichens. Okay, so you have inorganic and organic. So as we go through the different types of products and stains and all that, we're going to be talking, this is the product. Is it useful for inorganic stains, or both? Okay. Let's talk the number one biggest thing that we use. What is the chemical or cleaning solution that we use the most of? Hint, it's not bleach. It's water. Water is not just water. Water is also a chemical. H2O. Everybody knows it, right? Agua. So water is the number one chemical that we use. Our cleaning solutions are not mostly bleach. The strongest bleach solution that we use is 4%. 4% of the total solution is the bleach molecule. That means 96% of the water solution that's just bleach and water, you mix it together, 4% of what's in the ingredients there is the bleach molecule, 96% is H2O. And that's strong. That's strong bleach, right? You buy it in a bottle in a store, it's typically 6.5 to 8.5%. The bleach that we get, and in the place that we get it and where we buy it from, it's rated at 12.5% minimum. We get ours at about 13.3. Okay, 13.2. It's very strong. So 0.4 or 4%. Think about that. It's mostly water still. So water is the number one chemical that we use. So we'll talk disinfectants though. There's basically like there's a couple different grades or different types of disinfectants. I'm going to talk about primarily the two that we use, and we'll talk a little bit about this other one that we use occasionally. And there are some others that people would consider disinfectants, but they would be terribly ineffective at what we do. So the number one bleach that we use would be sodium hypochlorite. That's bleach. People call it chlorine bleach. People call it pool chlorine, liquid bleach. It's sodium hypochlorite. And a lot of guys like to call it SH, sodium hypochlorite. If you like and care, it's NaOCl is the scientific formula. It is sodium hypochlorite. It's terribly effective. It's a disinfectant. Let me tell you the reasons why we use it. Okay. We use bleach because it's widely available, cost effective, terribly cheap compared to other disinfectants, legal to transport. Okay, there's some DOT regulations around it, but we get to carry a lot of it. Generally, we get to carry plenty of it to any job we do. It's very fast acting. Okay, in the range of what we need to kill, it kills all of those things. So it's applicable to what we need to clean. Bleach, in contrary to what you might think or hear, bleach doesn't kill everything. Bleach doesn't kill the AIDS virus. Okay, lye kills the AIDS virus. So there are other disinfectants that would be more effective at killing more things. But generally, bleach in all the categories or descriptions, rather, that we just gave it, all those other products would have the opposite. Not as easily available, more restrictions or legalities around how to transport it, slower acting, more money, Um, it kills the broad spectrum of what we need it to. These other disinfectants, on the other hand, would actually kill more, some of them, but we don't need them to kill that kind of stuff, right? We're not killing the AIDS virus on buildings, okay? So we need a product that kills what we have. So bleach, liquid bleach, is a terribly effective and appropriate solution for what we do. It has its consequences. We get to that in other chapters, but it does what we need it to do. There's another product called calcium hypochlorite. People call this powdered bleach, okay? Sodium hypochlorite, calcium hypochlorite. That's the difference. One's made from sodium, one's made from calcium. Now, big difference, calcium would be good for the soil and good for the plants. Sodium, not so much. Okay? Downside of calcium hypochlorite is it's more cumbersome and difficult to use. It's powdered. You'd have to dissolve it and then use it. Okay? We can't just mix it up in our trucks and then drive down the road and use it. You'd mix it when you need it as a shorter, what's called shelf life. It wouldn't last as long. Okay? Sorry, back to the sodium. Biodegradable, legal to percolate. That bleach runs out onto the ground and soaks into the ground. The EPA doesn't come along and write us a ticket. It's legal to put it into the ground. Okay? Um, and biodegradable means it breaks down to components in 20 days. Okay? It'll break apart into components and be less effective, less bleach, called inert, no longer effective, no longer bleach. Calcium hypochlorite carries those same things. Downside of calcium hypochlorite or powdered bleach is that you can't make it but so strong. You'll never get a 3% solution out of calcium hypochlorite. So you couldn't clean a roof with it very effectively. It would be very slow acting. If you try to clean a roof with 1%, you can eventually. It would take many coats, apply it, let it dry, apply it, let it dry, probably 10, let's just say 10 or 15 coats. Well, calcium would be similar. Calcium makes about a 1% solution. So it's difficult to clean with because that's about the most you can get out of it. Okay. We don't use that pretty much by and large. I've used it before. We're not going to use it again. I can't see a scenario where we would use that again. So I'm telling you about it so you know something about it, so you're educated, but we're not going to use it. The other products you could use would be called, people call it oxygenated bleach. By and large, you're talking about hydrogen peroxide, H2O2. Sounds very similar to water because it is. Hydrogen peroxide, when you see it in the little brown bottles and it bubbles off, what you're seeing is the oxygen release out of the H2O2, and what you're left with is water. So as peroxide is used up and disinfects and kills things, like you put it on a wound, a cut, it'll disinfect that and it'll give off oxygen, and you're left with water. So in time, your hydrogen peroxide just becomes water. So in that way, it's a safe, not, I won't call it safer, safe product to use, legal to percolate, all that kind of stuff. It will have less of an effect on plants, but it will have an effect on plants. People that market and sell a product that we buy, that we use occasionally as an oxygenated bleach solution for that particular client, sell us this stuff and tell us no worries about the plants. I found that to not be true. Still affects the plants a whole lot less. Easier to work with as far as plant care. Similarly, it's not quite as strong, and it takes quite a bit longer to act, and it is way more expensive, whole lot more money. So, slower acting, costs more money, easier on the plants. Not a good trade-off. We have a proven system with sodium hypochlorite where we can remediate against the plant trouble, not have an issue, use a product that costs about 10 cents on the dollar versus the peroxide type product. Okay. And works way more fast. Like the sodium hypochlorite's way faster acting than the peroxide product. Okay. Then you get into some other products like sodium percarbonate, sodium metasilicate, even vinegar. Vinegar has a disinfecting quality to it with enough dwell time, can kill some things. Never would be effective at what we do. The dwell time would kill us. We'd be at a house all week long trying to spray a roof with vinegar to eventually make everything die. The product costs alone would stagger the client, let alone the time for the bill for our time. Okay. The other products I mentioned are products that we can use, have used. Um, if you ever had cause to need them, you would get a lesson and it would be a deliberate job. You'd have supervisors on the job, and the price of the job would shock you because we're not going to give it away if it requires that much time. So they're really not relevant to our disinfectant discussion. Next thing we're going to talk about is what's the next thing we add in? Generally, we call it soap. Okay. So the house wash or the house mix or the general house soap, as we call it, uh, is used on roofs, houses, awnings, decks, patios, everything. Um, the primary purpose of our soap is two things. I'm going to mix two categories here. So you have soap. What does a soap do? It cleans. It's cleaning power, right? Big fancy word. Write this down. It's called emulsification. 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 Big fancy word for this. Okay. Let's say you have dirt, whatever it is, dead material, dead algae, whatever, and it's on the surface, right? Emulsification is nothing more than this. You put liquid on there, and then you're going to rinse it with water. Emulsification is kind of like this. Picture a glass of water with dirt at the bottom, okay? And you put the little stir in there, and you go and stir it up. It's suspended into solution. Picks it up and lifts it up and makes it part of the solution. It's kind of what emulsification is. So it's like a kind of like a description of the cleaning power of the product. Can it grab a hold of it and lift it off of the surface it's on and make it part of the solution that we applied? So you have a cleaning solution, which again is mostly water. You have some bleach in it that we just described. Now you've got this house soap in it. The job of that product is to grab a hold of it and make it part of that solution instead of attached to the material that it was once on. That goes for the algae, the actual dirt, dirtiness, the spider webs, the bugs' nests, and little mud daubers and all that stuff. Remember we said we'd get back to that? So the soaps that we have a special ingredient in it that's added. Okay. I'll go back to the description of this. That's added so that it grabs that dirt and breaks it apart. This isn't just dissolving the mud with water. There's a product in the house mix, in the general soap that we use. It's there on purpose to do this very thing, to grab anything and dig it up and make it part of the solution. And especially effective at grabbing stuff like dirt, like a mud dauber, and breaking it down. The other thing it does is it attacks the glue. Think of it as the glue of a spider web. So spider webs like made out of that silk-like material, and then it's got like an adhesive to it. It doesn't attack the silk stuff. It attacks the adhesive property of the spider web. And if you've seen us apply solution to a spider web, it just goes into an instant tiny little ball, barely bigger than the spider. All that silk just disappears and washes it off. You try to do that with a power washer or even a broom, you're not going to get it all. The cleaning solution is terribly effective at getting rid of all of that. So the soap quality is there in a very general sense to clean. If there's any dirtiness to the surface that you are cleaning, sometimes you require agitation. Think like a deck. Soft bristle, that blue brush. You agitate it lightly. You are actually cleaning dirt, and you have soap in there that'll help you do that. And the other property of that is called the surfactant. Best description I can give you of our surfactant, I've even thought of private labeling it and calling it that, liquid Velcro. Okay? That's what it does. Makes it adhere. Okay? So if we were to turn up the surfactant quality of our soap on the dial or add a whole lot more to it, and it makes the stuff stick like Velcro, I want it to stick enough so that it doesn't just run down to the ground. So when on the roof, it doesn't just readily run off the roof. But if I make it extra super heavy duty foamy, by the way, that's when you know you have a surfactant, is when you see foam. Okay. If we made it super foamy, what would happen when we tried to rinse it? It's Velcro.
It's gonna stick.
If I make a light Velcro and I put a little pull on it, it comes off. But it made it stick. If I put that kind of Velcro on there, what's it take to remove it? It'll take like 10 times as much water. You'll rinse and all these bubbles will just keep running and running and running and running and running. So we put enough in there to make it stick. The balance game is that there's enough to make it stick, but not so much that it makes it so long to rinse. So we can make it stickier, like a roof. We're not going to rinse most roofs. So you turn up the dial on the surfactant or the soap when you do a roof. Don't we tell you that? Hey man, what do you put it on these days? 100? 90?
100.
Huh?
100.
On the roof? What do you put it on?
Soap.
Soap on a roof. You're not sure right now. That's okay.
No, I thought it was like, me personally, I thought it was like 60, 80.
Yeah, it could be 80. I wouldn't be shy to put it on 100 just for the roof. You don't want to try to rinse away the dial on 100 with the soap, like on a house. It'd be too long rinsing. But you don't want it to come off the roof. Okay? Point is, more surfactant makes it stick. So you put a little bit of soap, you put a lot of soap, surfactant. You put a whole lot, and it gets hard to rinse off. Okay? Just suds up on you. But that's the qualities that are in the soap. We want to talk other products. Okay, organic, inorganic. Got to go back to that discussion. So far, the disinfectant, the house soap, which has soap and surfactant qualities. We're talking about pretty much an organic infestation. Those products are applied to are organic solutions to organic problems, not the inorganic. Okay, we don't need any of those qualities when it comes to. We don't need any of those qualities when it comes to um, cleaning up inorganic stains. Okay, we haven't gotten to those yet. Now we're going to talk one that's a little bit in between gutters, exteriors of gutters, gutter brightening. Okay, the soap itself is, and by the way, all of this stuff on pH scale. Everybody know what this is? High pH. It's called alkaline or basic, right? Below 7 pH, 6, 5, 4, 3, 2. Those are acidic products. Okay, an example of an acidic product that you can consume, regularly: orange juice, any type of juice, grapefruit juice, acetic acid, okay, vitamin C, okay. Orange juice has acids in it. That's why it has that little bit of a sharp twang to it. Um, Alkaline products that you might use. You buy baking soda, you can bake with it, okay. Baking soda is mostly used as you put in your fridge for the odors and all that kind of stuff, but it's an alkaline product, okay. Um, all the products we've talked about so far have high alkalinity. They are cleaning soaps. Generally, your cleaning categories are going to be above pH 7. The bad thing about that is your plants do not like, generally, high pH environments. They like them somewhere around neutral to slightly acidic. Okay, so we're taking them the other direction. That's part of why our products have to have, we call it neutralizer, because we're taking the bleach and making it not bleach anymore, right? We'll get to that. We're almost there with the chemicals. Let's talk gutter brightening. Gutter brightening is a soap, and its primary job is to take those black streaks and dinginess off of gutters. So its primary component is still a high alkaline product. It's a really good soap in terms of pure cleaning power. If I ever want to wash my vehicle and I had either the house soap or gutter brightener, I would prefer gutter brightener. Okay? As a soap. We don't use it on the house and the roofs and everything else because it's got a product in it that makes it terribly effective at gutter brightening, but not something you would want on your roof. Okay? Talking about chemistry, we'll back up a little bit. The house soap, I'm going to contrast that to the gutter brightener. House soap does a terrible job, really terrible job of taking the oils out of an asphalt shingle roof. Isn't that something we want it to be terrible at? Right? We want it to be terrible at that. Um, the gutter brightener would do a much better job of pulling the oils out of the shingle roof. So we don't want that. So we don't use that by and large to wash a house or roof. Be better substituted for the house, terrible substitution for the roof. Gutter brightener, what it does is because it has that other ingredient in it, that it's going to clean up the gutters really well. The oxidation or the striping or the dinginess of the gutter, it's not, um, uh, sorry, it's not oils from the roof. Those oils didn't come down off the shingle, jump over the gutter, and land on the outside of the gutter and run down. Okay? It's not dirtiness from overflow and the gutter is flowing down and it's dirt and stuff. It is the paint. It's not on the paint, it is the paint. What makes exterior paints more effective, the bond through the weather and the sun and everything else, is what makes them bond is the metals that are infused in the paint, part of the ingredients, like zinc. What color is zinc oxide? Surprise, surprise, it's black. That's why you have dinginess and black stripes on your gutters, because the zinc itself oxidizes in the paint, and now you have stripes on the gutters. So what this soap is good at is think of it as a chemical exfoliant. Everybody know what that like Mary Kay stuff is? Like you put it on your hands, the scrub stuff, the mask. You do like this, and then your face is green, and you let it sit there, and then when it dries, you peel it off. That's an exfoliant. It's taking like dead skin and making your skin real smooth. Well, chemically, that's kind of like what we're trying to do to the gutter or the white paint, is we exfoliate it and take the damaged paint off. And so you get back to what's under it, some more of the white paint that's not compromised. That's why after a while, you scrub and the gutter gets darker, not lighter, because you got through enough paint, you're down to the aluminum. And that's darker and now shiny, right? So that's the chemistry that's in the gutter brightener. It's a soap, but it's a type of product that's good at doing that. It's specifically formulated to do that. We don't have another purpose for it. Okay? It's made to do that. So that's oxidation. When you have oxidation on the siding or whatever, that product would take that off more effectively than other products that we have. That's a combination of organic, inorganic problem. It's a little more inorganic, but it's done in our soft washing process, which is an organic cleanup. But then gutter brightening is an inorganic stain. So it does remember time, temperature, turbulence. We use some turbulence, some light agitation, not heavy scrubbing, light agitation to move the product across there and let the chemistry do the work. But a little agitation helps. Now we move into inorganic stains. We're going to go through these quickly because these are specialties that you'll learn at another time when they become applicable to you as a lead tech to know. So rust stains, efflorescent stains, and graffiti removal. By and large, those are acidic. The solutions to that are acidic. Rust is comes from iron. It's iron oxide. So it is just like oxidation, except that it's a description for a specific metals oxidation process. Iron oxide. Okay? And you know what it looks like? It's rust colored. It's so common. The color of rust is named after rust, right? That orange looking color, when you see that, you know it's rust. The solution is a particular product that we use, and you apply it with a pump sprayer typically, right? You want to aspirate it on there, get it on there lightly, like we do a lot of our chemical applications. We'll get into more technique later, but you guys already know some of that it's a light application, multiple light applications. So you wet it, you let it loosen it up, the chemicals loosen it up, and in this application, you come behind with one of those nasty pressure washers and pressure wash it off. Some surfaces, again, we'll get into more details later, but you might scrub it like on vinyl. The point is you use an acidic product to remove an inorganic stain. Efflorescence is an inorganic stain. Generally, they're called calcium salts. You'll notice them as the white powdery or white hard substances on natural stone, composite stones, brick and mortar. Okay. Haziness, drips, hard lines in the brick and mortar, right at the mortar lines. You have efflorescence, and then you have a product or a material called calcite. It's really hard and difficult to remove. It's a specialty acidic product that you apply to that. And again, pressure wash it off, done multiple times. You can do a really good job of getting rid of most or all of it. Okay. Again, more lessons later. Graffiti remover is a product that attacks, think of it as attacking, just like the soap attacks the stickiness of a spider web. Well, graffiti remover attacks the stickiness or the adhesive properties of spray paint. So it's not really attacking the paint like acetone or paint thinner. It attacks the stickiness of the paint. And so when you see it's really cool, it's magical looking. You put the product up there. When you see it begin to bleed a little bit, it's done. You put hot water, not just a pressure washer. You don't need the pressure. The pressure washer at that point acts as a boiler to make the water hot. You apply the water on there, and you'll see it just run down like a cartoon, just fall off the wall. Really cool looking. Can be done safely even on more delicate surfaces like vinyl, you know, or painted surfaces. And generally, the product will have minimal effect on the paint. That what's really going to have an effect on it is the spray paint itself can damage the paint, the underlying paint, and leave an outline of it. Okay. So that's basically inorganic stain removal. So our general chemistry is organic problems require disinfectants and soaps to remove them, kill the stuff and pick it up in solution and rinse it away with water. The inorganic stain generally requires acidic products to, again, emulsification. That's what those acidic products do. They emulsify that stain, dirt, efflorescence, rust. They emulsify that, break it apart, and then the pressure washer, it makes it loose, and then the pressure washer can knock it off. Okay. Graffiti remover, similar process, but you need the heat to make it effective. If you try to do graffiti removal with cold water, you'll get half a result. Sometimes you can make it really hard on yourself, because then when you go back with heat and try to do it right, and we've done this before, where a technician didn't follow instructions and used the pressure washer without the heat, we went back to fix it, and we had to go to war with it to get it to come off because it no longer had that sticky property. Okay. So you have inorganic stains, you have organic stains, and you have a different chemistry approach. What you'll find generally is an organic living approach or problem takes a high alkalinity of solution, and inorganic stuff in general is going to take a low alkalinity. The exception to that would be the gutter brightener is kind of like in between. It's actually a higher pH soap, but what it's doing to that paint in chemically exfoliating it is effective with light agitation, no need for a pressure washer. Pressure washer might be damaging and take too much of the paint off. So that's a good explanation. That's the basic chemistry of what we do here. Um, we didn't cover plant wash. We'll cover the chemistry of plant wash when we talk about plants. So we'll see you on the next one.